Robots aren't just machines anymore, they're starting to act human. They walk like us, talk like us, even react with emotion. From AgiBot's humanoid greeting people in public, to XPENG's dancing android that fooled the internet, and Toyota's walking chair that climbs stairs like a pet, AI has officially crossed into the uncanny valley. And maybe, into everyday life. This is new AI robot acts shockingly human in public. AgiBot A2. The A2 is described as a humanoid service industrial robot built around human ergonomics.G, about 169 centimeters tall, 69 kilograms, various sources approximate. It's designed for real-world human-facing tasks, reception desks, lobbies, exhibitions, etc. According to one review, its versatility is a major plus, whether it's customer service, manufacturing, or research. The company claims advanced AI, perception, navigation, manipulation, multiple sensors, camera lead air depth, and high dexterity. AgiBot is also moving towards mass production. According to a Wikipedia summary, founded in 2023, and by late 2024 had produced 962 units. One spec list: 169 centimeters tall, 69 kilograms weight, turning radius 60 centimeters. According to Top Gear, the machine is 169 centimeters tall, 5 feet 7 inches, weighs 69 kilograms, and has a turning radius of 60 centimeters. Because it's designed for business or service settings rather than purely research demo, it may be among the first humanoids to actually be seen in the wild in meaningful environments, not just a static demo. The fact that the company has scaled toward production means you might start seeing these in places like large HQs, exhibition venues, possibly even public-facing roles. Open questions: cost, reliability, maintenance in the field, how long continuous operation lasts, battery, wear and tear, how well the AI handles true wild conditions, not just demo labs. Some reviews point out that long-term feedback is still limited. AgiBot A2 is a serious contender in the humanoid service/industrial robot space, less flashy than some showy demos, but with strong potential for actual deployment. If you were guessing which robot people might actually see around in near-future public-facing roles, this is a good bet. XPENG, better known as an EV automotive company, has unveiled a humanoid robot called Iron. The headline features of the robot danced a routine which was reportedly learned in only 2 hours using imitation learning methods. Humanoids daily. It has 82 degrees of freedom and a human-like spine design, allowing the waist hips to move in sync, enabling more fluid, human-like motion. XPENG revealed a bare metal version, no coverings, to prove it wasn't a person in a suit. They literally unzipped the robot on stage to show internal mechanics. They're talking customization, appearance, body type, even synthetic skin, full body synthetic skin intended to make it feel warmer and more intimate. The robot is described as aimed at roles like reception, tour guide, personal assistant rather than heavy industrial tasks. What's interesting, what to watch? The learning in 2 hours headline is very strong if it holds up, because learning new motions adaptations is one of the big bottlenecks for humanoids. The aesthetic human form angle, including the customization and synthetic skin, raises a host of questions about human-robot interaction, trust, comfort, and discomfort. Because XPENG is an automotive tech company, they may leverage their manufacturing, sensor AI stack, and mass production capabilities to push rapidly. On the flip side, flashy demos don't always translate to robust, field-ready systems. You'll want to ask, how many units built, what environments have been tested, dynamic real-world versus controlled, how it handles failure, safety, cost, maintainability. XPENG's Iron is bold and attention-grabbing. It leans more toward human-robot companion service with a strong emphasis on looks, motion, and interaction. It may be slightly less grounded in industrial deployment, at least at present, than a robot like AgiBot A2. But it raises the bar on what humanoids feel like and look like. The fact that multiple companies are now talking about humanoids that walk, talk, move, and are intended for real environments, not just showrooms, is a big shift. The weirdness factor: you mentioned robots with human forms, curves. Customization isn't just aesthetics, it signals a push toward robots that integrate into human spaces socially, not just functionally. Safety: in human-populated environments, every failure, trip, bump, misrecognition becomes high stakes. Reliability and maintenance: robots walking around complex, changing environments is hard. Battery, wear on joints, sensor calibration, software updates, all operational issues. Cost versus value: will deploying these make business sense for hotels, lobbies, etc.? Will they outperform humans in cost-benefit terms? Implications: appearance, e.g., body types, synthetic skin will trigger social responses, comfort, distrust, uncanny valley. The fact that one company is offering breast size customization, if the reports are accurate, begs questions about objectification, gender, and the social role of robots. Software autonomy: the heavy lifting is in perception, decision, motion. The more these machines move into open, unstructured environments, the more edge cases they must handle. From a business real-world perspective, the shift from demo-only to deployment possible is underway. You might start seeing these bots in hotels, exhibition centers, high-end retail, etc. before they become common in homes. Toyota Motor Corporation, Walk Me Four-Legged Walking Robot Chair Concept. At the Japan Mobility Show 2025, Toyota unveiled a concept called Walk Me, a robotic chair or mobility platform that walks on four articulated legs rather than rolling on wheels. Interesting engineering. The design intent: assist people with limited mobility to navigate environments where conventional wheelchairs struggle, for example staircases, uneven ground, obstacles. For legs with multiple sensors plus actuators, enabling real-time adaptation to terrain, each leg individually controlled, inspired by animals, goats, crabs that handle rough terrain. LiDAR radar weight sensors and automatic stabilization system, the occupant stays balanced on slopes or rough surfaces. Voice commands plus manual override handles for direction speed. Display showing battery and distance, foldable legs so the device can be stored more compactly when not in use. It's still a concept, no timeline for mass consumer release announced yet. Mobility beyond wheels. Wheels are excellent on flat, regular terrain, but stairs, curbs, uneven terrain are major obstacles for many mobility devices. This walking leg concept attempts to leap that boundary. Human space fit. Many buildings and environments are built for humans: stairs, steps, route changes. A walking chair could integrate more fluidly. Ergonomics and dignity. For users, being able to move naturally in their environment rather than restricted to accessible ramps etc. could bring improved quality of life. Robotics meets real assistive tech. While many robotic demos are focused on cool moves, this concept is oriented toward assistive mobility, which has large social market potential. Foldability storage. The fact the legs retract fold means the device can be designed with practicality in mind: storage in car, home rather than only lab demonstration. Warning, caveats and what to watch. Prototype stage. It is a concept. Many times what is shown in showrooms takes years if ever to become consumer ready. Safety and reliability. Walking on legs is mechanically and control-wise more complex, leg coordination, power consumption, failure modes than rolling on wheels. For mobility impaired users, safety is paramount. Cost, maintenance and weight. Complex legs, actuators, sensors typically mean higher cost, heavier equipment, more maintenance, all important in real-world assistive devices. Speed efficiency trade-offs. Wheels are efficient, legged movement tends to be slower and more energy intensive. Users may care more about reliability and ease than walking like a crab novelty. Infrastructure and user fit. Even if the chair climbs stairs, how widespread are environments where this is necessary versus better ramping, redesigning spaces? Sometimes simpler solutions win. User ergonomic fit. For mobility chairs, support, comfort, safety straps, posture, etc. matter a lot. The concept must evolve for real users. Reddit comments. See below. Flagged potential issues. I mean, it's gorgeous, but the side grips are the only grips? Most people who need this much help require belts to keep them in the seat.